All right, howdy everyone. We're going to calculate some limits of indeterminate forms with the trick of algebraic conjugates. So here's our example. X squared minus 3 all over x minus root 3 as x is converging to root 3. This is indeed an indeterminate form since the top, the numerator, is trying to converge to 3 minus 3, which is 0. And the denominator, the bottom, is trying to converge to root 3 minus root 3, which is 0. So this is indeterminate. Now that 0 in the denominator is really what's causing problems. You can't just plug in root 3 for x everywhere. So you need some type of trick. Now there are many ways to do this, and we are going to use algebraic conjugates, which is a common thing to do when you have a square root like that. So it's the limit as x goes to the square root of 3, and we're going to copy the original problem, x squared minus 3, x minus root 3, and then we're going to multiply by 1 in a fancy way, namely by the algebraic conjugate in the numerator and denominator. So the algebraic conjugate of x minus root 3 is x plus root 3. And to keep things equal, you have to multiply by that on the top as well, so that you're only multiplying by 1. All right, so this has the advantage that the bottom cleans up nicely. That when you multiply, remember this a minus b times a plus b is a squared minus b squared. Well, that's the rule we're using here. So you end up with x squared minus the square root of 3 squared, which is just 3 in the denominator. So x squared minus 3 in the denominator. And on the top, we have x squared minus 3 and an x plus the square root of 3. Now, we don't want to multiply that top out because we can see already we've got great cancellation going on. So it's the limit as x goes to the square root of 3 of x plus the square root of 3. And now you can just see that converges to the square root of 3 plus the square root of 3, which is twice the square root of 3. And that's it. Ciao.